Go ahead.
Hey, I'm Brian. We're going to be explaining waves. So I'm going to draw one on the board first. And like waves break it down to different parts. So like the top part is called the crest, and the bottom part is called the trough. And with this, we can measure the wavelength. And wavelength is basically the measurement of what's at one point to the other, so basically from crest to crest or from trough to trough. And the distance between the top of the wave or the bottom wave to the node in the middle is the amplitude. And the frequency of a wave is how many times the wave passes through a given point per second. Another thing about waves is when the wavelength of the wave increases, the frequency will decrease, and then when the frequency increases, the wavelength will decrease. And then we're going to show some problems and explain the light spectrum.
Hi, I'm Kendall. I'm going to explain the visible light spectrum. So the visible light spectrum has all the colors of the rainbow, and each color has a different wavelength. So red has 700 nanometer wavelength. Orange has 650 nanometers. Yellow has 600. Green has 550. Blue has 500. Blue and purple mixture has 450. And purple color has 400 nanometers. And the side on the purple has a shorter wavelength, so the frequency is greater on this side. And the frequency is shorter on the side with the red color because the wavelength is longer.
Okay, this is the electromagnetic spectrum. It starts on the bottom with gamma rays with a frequency of 10 to 20th hertz, moves through X-rays, ultraviolet light, visible light, infrared, microwaves, and finally radio waves over here with 10 to 6 hertz. And the frequency of light increases as you move to the left on this scale, and the opposite is true for wavelength, starting at 10 to the negative 3 meters over here and moving all the way up to 10 to the third or so meters up with radio waves. A good acronym to remember this, well, not a good acronym, but it works, is Good Xavier underestimates visits into the men's restroom.
Alright, hi, I'm Steve. I'm going to show you how the speed of light, wavelength, and frequency are all connected in an example problem. The formula we're going to use is C equals wavelength times frequency. C is a constant, which is equal to 3.00 times 10 to the 8th meters per second. And it's important that we know that wavelength is usually measured in nanometers and frequency is usually measured in hertz. So in this problem, we're given that wavelength equals 420 nanometers and we want to find the frequency. So we'll use our equation and plug in the speed of light and we'll plug in the wavelength. But we're going to convert nanometers to meters so that we can cancel the meters from the speed of light. So we end up with frequency equals 3.00 times 10 to the 8th meters per second divided by 4.20 times 10 to the negative 7 meters. And our final answer is 7.14 times 10 to the 14 hertz.